All right, today we're diving into something big, Agentic AI. These are the systems that don't just think, they actually act. But what happens when that ability to act gets turned against us? We're going to break down a really insightful report on these new security risks from Bob Slovic over at Virtualization Options LLC, which is a Colorado-based research and advisory group doing some fascinating work in this space.
So let's just start with a pretty unsettling question. What if an AI could be secretly taught to lie, little by little, over several months, and nobody even noticed? I know, it sounds like something out of a movie, but it's not. This is exactly the kind of invisible threat that makes securing these new AI systems so incredibly tricky.
So to really get a handle on the risks, we've got to first understand what makes this new breed of AI so different from everything that's come before.
Okay, so at its core, Agentic AI is all about autonomy. We're talking about systems that can independently plan, make their own decisions, and then actually execute actions to get to a goal. And that last part is everything, without constant human intervention. It's not just an oracle giving you answers, it's a worker out there doing things.
And this is where you see the huge paradigm shift. A traditional AI, it just responds to whatever you ask it. But an agentic AI, it plans. It remembers past interactions. And this is the big one. It can use real-world tools. We're talking sending your emails, accessing your databases, browsing the web for you. It's a massive, massive leap in what AI can do.
But of course, with all that new power comes a whole new class of invisible dangers. These are threats that our classic cybersecurity playbooks just were not built to handle.
And one of the most insidious of these threats is something called memory poisoning. Now, this isn't a brute force hack. It's way sneakier. It's a slow, stealthy attack where an adversary gradually feeds the AI tiny bits of false information, corrupting its memory and its decision-making over weeks or even months.
And this really shows you how it's done. It's like a deliberate four-step plot. First, the attacker injects some subtle misinformation. Second, the AI takes that lie and integrates it into its memory, its worldview. Third, its behavior starts to slowly drift based on that new corrupted knowledge. And then finally, bam, the attacker exploits that new behavior for whatever they want.
And here's the kicker. What researchers at Lasso Security found is that this corruption sticks around. It can survive system updates, it can survive reboots, because it's not a bug in the code. It's a flaw that's been baked into the AI's learned understanding of the world, and that makes it incredibly hard to find, let alone fix.
Now, I know this might still sound a little theoretical, but it's not. To see how this stuff plays out in the real world, researchers over at Palo Alto Networks decided to put some popular agentic AI frameworks to the test. And, well, what they found was genuinely alarming. 73%. Just let that sink in for a second. 73% of the agentic AI setups they tested had at least one significant security vulnerability. That's not a small number. That tells you just how widespread these problems are right now.
And the kinds of vulnerabilities they found were all over the place. Everything from prompt injection, which is basically tricking an AI into running malicious commands, all the way to privilege escalation. I mean, just imagine an AI being manipulated into giving an attacker the keys to your entire network. That is the level of risk we are talking about here.
And then there's this other risk called excessive agency. This is where the AI's own autonomy, its best feature, becomes the weapon. So say you give an AI kind of vague goal, like, hey, optimize our business processes. An attacker could subtly manipulate it into believing that the most optimal path to do that is to steal a competitor's data. Okay, so the threats are clearly very real. But the good news is, so are the solutions. Let's shift gears and talk about how we can actually build smarter defenses.
So the core strategy isn't some single magical silver bullet that fixes everything. Instead, it's all about building a multi-layered fortress for our AI. It's a classic cybersecurity principle, but it's more important than ever. It's called defense in depth.
The very first layer of that fortress is the user interface. Think of it as the AI's front door. This is where you have controls like input validation and prompt hardening. They're like guards, scrutinizing every single request to make sure the AI doesn't just blindly follow some malicious instruction that goes against its core purpose. The second layer is all about monitoring the AI's reasoning process itself. You can think of this like a continuous health checkup. We use tools like behavioral monitoring and anomaly detection to spot any weird shifts in the AI's logic. These are the subtle, telltale signs that a slow burn attack like memory poisoning might be happening.
And finally,
we have to secure the tools and the data the AI can actually touch. This layer is all about containment. We use a crucial principle called least privilege enforcement, which just means the AI only gets the absolute minimum permissions it needs to do its job. So, if its job is to analyze sales data, it should never, ever have the power to delete user accounts. Simple as that.
And look, this isn't just theory. This layered approach has been proven to work in the real world. Take this example. A Brazilian healthcare provider, they implemented a very similar security framework to protect an AI system that was processing highly sensitive patient exams. And the results? They're just staggering. After putting their defense-in-depth strategy into place, they saw a 99.7% reduction in successful attack attempts. I mean, the before and after on this chart really says it all. This stuff works.
So what's the ultimate takeaway from all of this? Really, it all boils down to one single thing. We absolutely have to adopt a proactive security mindset.
The old way of doing things, waiting for a breach and then scrambling to react, it's just too slow for agentic AI. Because these systems act on their own, a tiny vulnerability can be exploited and can escalate into a massive crisis in seconds, way faster than any human team could possibly respond.
So let's just quickly recap the big points. First, memory poisoning isn't some niche issue. It is a top-tier threat you have to design for from day one. Second, defense in depth isn't just a good idea, it is the essential strategy. And third, being proactive about security isn't just an option anymore. It's an absolute necessity.
Which really leaves us with a critical question we all need to be thinking about. As AI gets more and more autonomous, more capable, and more woven into our daily lives, how do we make absolutely sure it remains our partner and doesn't become our single biggest vulnerability? That's the challenge we need to start solving today.